This is part 2 of the informational text article being read aloud. Seafloor spreading. Scientists continued to spread the idea of continental drift. During World War II, sounding gear produced new evidence of what the seafloor looked like. The gear, developed in the 1930s, bounced sound waves off the seafloor to determine its depth and features. Harry Hess, a geologist from Princeton University, was put in command of an attack transport ship. Hess, then in his late 30s, wanted to continue his scientific investigations even while at war. Ship commanders turned on sounding gear when approaching port or to help navigate a difficult landing. Hess, however, left his ship's gear on all the time. What Hess discovered was a big surprise. The bottom of the seafloor was not smooth as expected. In fact, it was full of canyons, trenches, and volcanic sea mountains. Exploration of the seafloor continued. By the 1950s, other researchers had found that a huge rift ran along the top of the Mid Atlantic Ridge. That enabled Hess to understand what he'd discovered about the ocean floor of the Pacific. He realized that the Earth's crust had been moving away on each side of the oceanic ridges. The ridges ran down the Atlantic and Pacific Oceans and were long and volcanically active. He published his theory in 1962, and it came to be called seafloor spreading. In the early 1960s, dating the ocean core samples showed that the ocean floor was younger at the Mid Atlantic Ridge. It became older and older in either direction. This confirmed that the seafloor was truly spreading. Further evidence came along by 1963. Geophysicists realized that the Earth's magnetic field had reversed polarity many times. Each reversal lasted fewer than 200,000 years. Rocks of the same age in the seafloor crust would have taken on the magnetic polarity at the time that part of the crust formed. Sure enough, surveys on either side of the Mid Atlantic Ridge found rocks with a pattern of alternating polarity stripes that clinched the argument for most geologists. Unlike Wegener, Hess lived to see his major theory accepted. He helped to plan the U.S. space program. On August 25th, 1969, he died of a heart attack. It was just a month after Apollo 11's successful mission to bring the first humans to the surface of the moon. Plate tectonics. By the 1970s, geologists had agreed to use the term plate tectonics. They had evidence that the continents move, but they'd also found evidence that to do so, whole plates of the Earth's crust. A plate might include a continent, parts of a continent, or undersea portions of the crust. Wegener's idea of continental drift had been taken a step further. Geologists today understand that the Earth's surface, or crust, is broken up into 8 to 12 large plates and 20 or so smaller ones. These plates move in different directions and at different speeds. Their size do not correspond to the land masses on top of them. For instance, the North American plate is much larger than the North American continent. The plate extends from the western coast of North America into the mid-Atlantic. Iceland is split down the middle. It belongs to two different plates. The continents have come together into one large mass and then split apart again more than once. Over the last 500 million years, this may have happened as many as 3 times. The force that moves the plates is thought to be convection currents in the mantle under the Earth's crust. The mantle is solid in the short term, but over long geologic time it does flow, though very slowly. Pockets of hot liquid magma ooze up along extensive mountain ridges deep under the water. One runs roughly north and south in the mid-Atlantic and another runs in the mid-Pacific. Along these ridges are found active volcanoes and hot water vents. Through these vents pour very hot mineral-rich water. Astonishing forms of life are supported by the nutrients in these waters, and these ecosystems are the only ones on Earth who survive in the absence of sunlight. It's possible that this is where the first living organisms of Earth developed. Where the edges of the plates meet, several things may happen. If both plates carry continents, which are lighter than the ocean floor, they may clash head-on, causing high mountains to rise. If one plate is heavier, it may go under the other, a process known as subduction. The material of the subducted plate returns to the mantle, recycling the Earth's crust. This is where I'm going to stop for right now. Part 3 is coming up.